All right, we're in chapter 10, Mathletes from Algebra Geo. So solving quadratics by factoring and the even root property. And we're going to potentially take a look at graphs of quadratic functions, depending on how long this video goes. So let's see if we can get to it. So strategy for solving quadratic equations by factoring. So we want to set one side equal to 0, right? Step 1. Step 2, factor the other side. Step 3, use the zero factor property to set each factor equal to 0. Step 4, we want to solve simpler equations. Those are going to be the binomial, usually the binomial factors. And then step 5, check the answer in the original equation. All right, and so let's try these out, or at least kind of practice factoring, right? So there's a few different types of factoring we can do. Number 1, we have a simple quadratic because we have a is equal to 1, the invisible 1 there in front. So that's the one where we can just set it up like this, put an x in front. We want to find numbers we can multiply to get 30, right? Multiply to get that c value, that in this case, and we want to subtract to get 13, right? Okay, so remember this, this tells you what you want to multiply to get, or what your product is, and then this tells you whether to add or subtract to get this number here. Okay, so you kind of read from right to left, so it's a little backwards from what we're used to seeing. So numbers we can multiply to get 30 that we can subtract to get 13. So if you don't know them right off the top of your head, you can make yourself a little factor, not a factor tree, but a list of factor pairs, right? And you can just keep going down the list. Once you get to the point where you're on the other side, like the next number after 5 would be 6, and you start getting on the other side, that's where you can stop, right? And so which of these subtract to get 13? And the answer would be ding ding ding, 2 and 15, right? So, and then we want our bigger number to be negative, okay, which means, and then since this is negative, that means we want the other one to be different, right? That tells us our signs are going to be different. So positive 2, negative 15. Okay, and remember that you can always double check if you just add these together, 2 minus 15, or negative 15 plus 2, you get negative 13, so that checks out. And if we multiply these, 2 positive 2 times negative 15, we get negative 30, so that checks out. So they should, the numbers you get, you can check them out pretty quickly just by adding them and multiplying them and see if those numbers come back. Or you can just FOIL and see if it works. All right, so that's a simple quadratic, right? Pretty straightforward. Here we have a complex quadratic for number 2 because 3, the coefficient of the squared term, or the squared variable, is greater than 1, right? So what we have to do here, so remember this is A, B, and C. The first thing we want to do is multiply A times C, okay? And so in this case, 3 times 5 is 15, okay? And then it kind of is similar to what we just did. We want to find numbers we can multiply to get 15. So instead of finding numbers we can multiply to get 5, we use that product that we just got. So numbers we can multiply to get 15 that we can add to get negative 8. Okay. So once again, we can make a list if we need to. You might already have the values off the top of your head. So 15, those are only possibilities. So which of those can we add to get 8, 3, and 5, right? This time, the bigger number is going to be negative. But this time, this is what's different, is that since we have a positive, that means our signs are going to be the same, right? So we get a negative 3 and a negative 5. Okay, so now I'm going to put them in here. So here's where it gets a little different. There's a few different ways you can do this, but no matter what method you choose, you're going to have to find those two values and multiply these together. Okay, so here's where it's a little different depending on your method. And this method I learned from a teacher a while back, and I really liked it. So anyway, so I'm going to put the minus 3 here and the minus 5 here. Okay, Now you might be thinking, well, if you were to FOIL this times this doesn't equal this, right? And you're right, but we're not done yet, okay? So now what we're gonna do is whatever this value is, whatever A is, you're gonna put that underneath each of the values that we just input, okay? That we, the real number of values, right? The constants. Okay, so then what's gonna happen is the 3's, 3 over 3 reduces to 1. Now 5 over 3 doesn't reduce, okay? Whatever you have left in the denominator after you reduce, you slide to the front, okay? So here, there's nothing to slide to the front, right? So it's just x minus 1. You could slide a 1 in the front, right? Because it's 1 over 1, but that would still be 1x minus 1. And then on this other one, here, we get 3x minus 5, okay? So now if it checks out, right? If I multiply x times 3x, I get 3c squared. I need to make sure that's a c instead of an x, okay? And then if I multiply 1 times negative 5, I get positive 5, right? So that checks out. And then my middle terms, if I do 3 times negative 1, I get negative 3x. And x times negative 5, I get negative 5x. And if I combine those, I would get negative 8x. Okay, so it checks out. Let me just change those x's to c's. So it'd be c minus 1, 3c minus 5. Okay, all right. Okay, number 3. So here we have a binomial, right? And there's a few different types of factoring we can do with binomials, but probably the most common one is difference of squares, right? So we know that, I'll write it here at the top, a squared minus b squared equals a plus b times a minus b. And we've been working with that both ways, right? We've been dealing with conjugates, complex conjugates is what we just finished. And so, so now we're factoring those and trying to come up with conjugates. So we're going to go here, and remember, all you have to do is take the square root of each of these terms, right? So the square root of a to the 4th is a squared, so that's going to go here and here. And the square root of 256 is 16, so that's going to go here and here, right? And then all we have to do, just like we see in the formula above, we're going to have a plus and a minus, right? Doesn't matter which order. Okay, now the thing here is we can factor some more. So you always want to check, is there anything more that we can do with this? This one we can't do. There's no sum of 2 squares formula, right? So that one's done. But here we have a difference of 2 squares again. So I'm just going to bring a squared plus 16 down, and then the a squared minus 16, I'm going to factor that. So I'm going to take the square root of a squared, which is a, square root of 16, which is 4, and then a plus and a minus, right? And now we can't do anything with that, so that's as far as we can go.